In this lesson, I'll show you how to solve a system of equations with fractional coefficients. This is question number 2. The question reads, solve simultaneously. As you read through these equations, you'll notice that they don't look like your ordinary linear equation. You have x plus this complex fraction and the same thing with equation number 2 at the bottom. The first thing that I'll do is distribute this 9y, this denominator, to the 3 terms in the numerator. Let's see what happens. So I'm going to focus on equation number 1 and then focus on equation number 2. X plus 2x over 9y. Notice I just distributed it to the 2x minus y over 9y plus 1 over 9y is equal to negative 16 over 9. I want to clear the denominator. We have 9's all across except for this term. So if I multiply this all by 9, here's what happens. We end up with 9 times x is 9x plus 9 times 2 divided by 9 is equal to 2x over y. This 9 and this 9 cancel out. 9 times y over 9y. This 9 and this 9 cancel out. And the y and the y cancel out, leaving us with minus 1. 9 times 1 over 9 gives us positive 1 over y. And 9 times negative 16 over 9 is equal to negative 16. Once you've done that, you want to clear the denominators again of the y's. And you can do that by multiplying everything by y. If I multiply everything by y, I get 9xy. And given the fact that we have 9 times x times y, means that this is not a linear equation. Moving on, 9 times 2x over y is plus 2x. This times this is minus y. This times that is plus 1. And negative 16 times y is negative 16y. Let's see if we can collect like terms. I'll take this term over to the other side. This gives us 9xy plus 2x plus 1 is equal to negative 16y plus y, which equates to negative 15y. The left side stays the way it is. This is the best I can do with equation number 1, so I'm going to work on equation 2 now, using the same technique. I'll distribute this 2 to the 3 terms above, and this 3 to the 2 terms. This gives me x over 2 minus 3y over 2 plus half minus x over 3 plus 2y over 3 is equal to 1. Just like I did in the first equation, I want to clear the denominator by multiplying it by the lowest common denominator. In our case is 6. Multiplying this by 6, I get 3x. Multiplying this by 6, I get 9y. This by 6 gives me positive 3 minus 2x. 6 times 2y is 12y, divided by 3 is positive 4y, and 6 times 1 is equal to 6. Take a look at this equation and compare it to the one that we have in red here. This one is purely linear, whereas this one is not. And like I mentioned before, we have x times y here, but we don't have that in this equation. Let's clean this up. 3x and minus 2x are like terms. That gives us simply x. Minus 9y plus 4 is minus 5y. And if I take this term over to the other side, I end up with 6 minus 3 gives us positive 3. What I'll do is isolate for x in this equation. I'll take this minus 5 over, and we end up with x is equal to 3 plus 5y. And I'll take the content of x and place it into all of the x's that I see in this equation. So I get 9y bracket 3 plus 5y plus 2 times 3 plus 5y plus 1 is equal to negative 15y. This equation now is exclusively in terms of y, and that's exactly what we want. 9y times 3 gives us 27y plus 45y squared plus 6 plus 10y plus 1 is equal to negative 15y. Collecting like terms, this term, and this term are alike. We can use our calculator to find out what that is. 27 plus 10. Bringing that over, negative 15 minus 37, we end up with negative 52. Negative 52y. 6 plus 1 is 7. And we also have 45y squared. This looks like a quadratic equation, so we might need to use the quadratic formula to find out what y is. For that, I need to put this in standard form, so I have 45y squared plus 52y plus 7, and this is equal to 0. Let's use the function on our calculator that enables us to find the roots of a quadratic. Typing in 45, 52, and 7 should give us negative 7 over 45 and negative 1. So given that we found two y coordinates, this means that we have two solutions. We're going to have 2 points of intersection. And to find the coordinates of both x and y, we already have y. We can substitute negative 1 into here, and we will end up with x is equal to negative 2. So one of our solutions is negative 2 and negative 1. If I substitute negative 7 over 45 into here, I'll end up with, well, let's use our calculator. We have 3 plus 5 times negative 7 over 45. This gives us 20 over 9. 20 over 9 and negative 7 over 45. And so there you have it. That is how to solve a system of equations with fractional coefficients.